everyone, this is Miss Drake. Today we'll be working on finding solutions to quadratics by factoring. So if you're in my class, it's lesson number 63 and will be on the bottom of the page. Okay, so what we're going to be looking at today are quadratic equations. And here's an example of a quadratic equation down here. A quadratic equation is going to have an x squared somewhere in it. It's an equation, so there's going to be an equal sign. And to solve an equation is to look for the value or values that make the equation true. So we're looking for a value of x that when you square it and add it to 7x plus 15, you'll get 5. Okay. So the standard form of a quadratic equation is this form that we were graphing in, ax squared plus bx plus c. But instead of when we were graphing it being y equals ax squared plus bx plus c, we take this expression and set it equal to 0. So a lot of times in this unit that equals 0 is going to be very important as we're solving any equation that has an x squared in it. Okay, the steps are a little bit different than solving when you have a regular x. When we have an x squared, we're going to be using factoring to help us find the values of x. And we're going to be using something called the zero product law, which is why we set the equation equal to 0. So your first step is to get it into this standard form. So to do that, we're going to move all the terms to the same side of the equal sign, which means basically we want this 5 to be over on this side. So to get the 5 over, I'm going to subtract 5 from both sides. So if I subtract 5 to this constant, I would either do one of two things. I would either stick it on the end if there was no constant to subtract from, but since there's a constant right here, I'll put minus 5 underneath that because they're like terms. Okay, so those cancel, and now I'm equal to 0 like I want. And I'm going to subtract 5 on this side. So x squared plus 7x, and then 15 minus 5 is, hopefully you said 10. Okay. So now I have my trinomial on the left and equal to 0. So now I'm in my standard form. Okay. So what I'm going to do is I'm going to take this expression on the left-hand side, I'm going to ignore the 0 for a second, and I'm going to factor this trinomial. Okay, so think when you're factoring a trinomial, you're going to go to a double bubble, right, or two sets of parentheses. And because a is 1, you know that this term and this term have to be x, because x times x is equal to x squared. And we're trying to figure out what these two numbers are. So you set up your table on the side. Depending on your teacher, they might call it FAXB or McCab. You're looking for two numbers that multiply to a times c that add to b. Well, let's look at our trinomial. A is 1, b is the number here, so 7, and c is 10. So you're taking those numbers in front, a, b, and c. So we're looking for two numbers that multiply to a times c, 1 times 10 is 10, and add to b, so add to 7. Okay, so you're going to list your factors of 10. We're trying to come up with two numbers that multiply to 10 and add up to 7. If you're really good with your factors, you might know this pair without making a table. That's totally fine. You don't need the table for your work in order to get credit. So if you know the pair already, you can just put those two numbers here. So I'm going to list the factors. Factors of 10. 1 times 10. Let's see. 1 plus 10 is 11. That is not 7, so that's not the pair. 2 times 5. Let's see. 2 plus 5 is 7. That's what I wanted. So that's my factor pair. Positive 2 and positive 5. If you list all the positive factors and none of them work, you would then go to your negative factors. So let's put plus 2 and plus 5 here. So this you learned during the last unit. What we're now going to do is use this zero product property to set each factor equal to 0. So if this times this is equal to 0, we know that either this binomial x plus 2 is equal to 0, or this binomial x plus 5 is equal to 0. So I'm breaking my factors into two separate equations. Now, there's no exponent on my x, so I can solve using my steps for solving equations that I learned in my first unit. So to get the x by itself, I would undo this addition with subtraction, so I would minus 2 on both sides, and I would get x equals 2. For this one, I would minus 5 on both sides. Okay, those 5's cancel, and you cancel those, and x equals negative 5. know what? 0 minus 2 is supposed to be negative 2. Sorry. So x equals negative 2 and x equals negative 5. So there's actually two solutions or two values of x that make this equation true. Okay? You can always check those solutions by substituting into the original equation. So I'll do my check down here. Okay, so we're saying that negative 2 makes this original equation true. So negative 2 squared plus 7 times negative 2 plus 15, is that equal to 5? Okay, so you would plug this whole thing into your calculator on Desmos and you should get 5. So that checks. Okay. If you want to check the other solution, negative 5, you would do the same thing. Negative 5 squared plus 7 times x, so 7 times negative 5, plus 15, is this equal to 5? Okay, and you would just, again, type this whole thing into Desmos or whatever calculator you're using at home, and it should give you 5. So both values actually check in the equation to make it true. Okay, so let's turn the page, and you should pause the video and try example 2. Okay, so hopefully you added 2 to both sides of the equation, and you got n squared minus 10n plus 24 equals 0. Okay? And then you want to factor this left-hand side. So because the variable is n, I know this is n, and then I'm looking for two numbers that multiply to a times c, so 1 times 24, multiply to 24, and add to b, so add to negative 10. If you want to write your letters up top, they multiply to a times c, and they add to b. Or if you have Miss Wire or Miss Iannone, they do factors of a times c with the sum of b. Okay, so I'm looking for two numbers that multiply to 24 and add to negative 10. Okay, so you go through your factors. 1 times 24, 2 times 12, 3 times 8. Let's see, none of them are adding to negative 10. 4 times 6. Now I'm going to stop for a second because 4 plus 6 is positive 10, but not negative 10. So that's not the factor pair. But if I want a negative, that means that either one or both of my numbers have to be negative. Let's see, negative 4 times negative 6 is positive 24, and then negative 4 plus negative 6 is negative 10. So this is my factor pair, n minus 4 and n minus 6. So now I'm going to set each factor pair equal to 0, each factor equal to 0. So n minus 4 equals 0, and n minus 6 equals 0. Okay, here I will add 4 to both sides, so n equals 4. And here I will add 6 to both sides, so n equals 6. So there are two solutions, n equals 4 and n equals 6. You may see this written in set notation where you have braces around the two solutions, 4, 6, which is another way of writing your solution, but most students just write it like this. Okay, we're going to do one more example where we're factoring when there is a GCF. Okay, so let's look down at example number 5. We're adding an extra step in here, which is to factor the GCF before you do anything. We still want it set equal to 0. We still want it in standard form. So I'm going to subtract 6 from both sides. And I have 6n squared minus 18n minus 24 equals 0. So before I factor my trinomial using the double bubble, I want to check for a GCF. So you're looking at these three numbers to see if there is a GCF. And we have a GCF of 6. So I'm going to divide all three terms by 6. I'm going to put the 6 on the outside, and then I have n squared minus 18 divided by 6 is 3, so I have 3n, minus 24 divided by 6 is 4, and this is equal to 0. Okay. Now I can factor the trinomial inside those parentheses. So I'm going to bring down this 6, and then I'm going to set up my double bubble, or my two sets of parentheses. The variable I'm using is n, so I'll put my n here. And I'm looking for two numbers that multiply to a times c and add to b. So a is 1. 1 times negative 4 is negative 4. So I'm looking for two numbers that multiply to negative 4 and add to b, so add to negative 3. So you think about your factors of negative 4. Negative 1 times 4, or 1 times negative 4, or 2 times negative 2 are really the only factor pairs I'm thinking of. So let's see, negative 1 plus 4 is equal to positive 3. That's no good. 1 plus negative 4 is negative 3. That's what I'm looking for. So my perfect pair is 1 and negative 4. So this is a positive 1. I'm going to put plus 1 here. This is a negative 4. I'm going to put minus 4 here. Okay, looks like I did not give you enough room in this packet. So before I send it home, I'm going to give you some extra space. I'm going to come over here to solve. I'm going to rewrite over here 6 times n plus 1 and n minus 4. Okay, I'm going to set each factor now equal to 0. So I have 3 factors, 6, n plus 1, and n minus 4. So the GCF, if you set that equal to 0, it's not true, so you basically just throw it out. When there's a GCF, you can kind of just forget about it. I'm going to then set each of these factors equal to 0. Okay, so here n plus 1 equals 0. How would I solve for n? Subtract 1 from both sides. So n equals negative 1. For this binomial, I would add 4 to both sides, and n equals 4. So again, this is for example 5. You have 2 solutions, n equals negative 1, and n equals 4. Okay, so we'll try the rest of the examples and the homework questions. Let me know if you are having any trouble. Have a good day.